Hello and welcome to Math 200 Online Statistics at Cañada College. My name is Lapuz. In this video, we will take a look at a homework assignment from section 8.4. We're going to assume that a simple random sample has been selected from a normally distributed population and test the given claim. We want to identify the null and alternative hypotheses, test statistic, p-value, state the final conclusion that addresses the original claim. Here's our problem. A safety administration conducted crash tests of child booster seats of cars. Listed below are the results of those tests with the measurements given in HIC, the standard head injury condition units. The safety requirements is that the HIC measurement should be less than 1000 HIC. Use a 0.05 significance level to test the claim that the sample is from a population with a mean less than 1000 HIC. Do the results suggest that all of the child booster seats meet the requirement? Alright. So we want the head injuries to be less than 1000. We just take a quick glance here. Most of it's less than 1000 except for one in the middle here. Okay. Alright. Let's do the hypothesis. And the claim again is that the sample has a mean that's less than 1000. So there's a mean that's less than 1000 here, but the less than symbol cannot be in the null hypothesis, so this isn't good. This has a less than 1000 here, and the null hypothesis has an equal to, and that is good. The part C says bigger than or equal to for the alternative hypothesis. That's not correct. And the last one, bigger than, less than. So our null hypothesis always has to have the condition of equality. And the only one with that choice is B. Okay. So now we want to find the test statistic, the p-value, and everything else. For this, we're going to go to Google Sheets, and since we have the data set here, we'll go ahead and copy this onto the clipboard and paste it onto our Google Sheets. Now, I have some information ready here because this is some of the information that we're going to need. We're going to need x bar. Oh, just by looking at the formula for your test statistic, we're going to need x bar, the mu sub x bar, so that's essentially what is involved with the null and alternative hypothesis. We need an s and an n. So all these come from the sample. So for our sample, we need the x bar, the mean, we need the standard deviation, and we need the number of numbers that's involved here. We are going to be given our mu, which in this case is 1000, and then we're asked to test. Let's take a look again. We're asked to use a 0.05 significance level. So our alpha is going to be 0.05. Okay, with that information, we should be able to figure out the rest of this. We need to fill this up, and we're going to first find the average, or the mean. The mean of all these numbers, and we need the standard deviation of all these numbers. And we know that there's 6 of them, and we're all set with our basic statistics for our data set. Now we can figure out our test statistic here. Our test statistic is according to this formula. The numerator is a subtraction, so we want to make sure we put parentheses around that. And the denominator is another fraction. Just to be safe, I'll put a parentheses around that as well. So we'll say equals, and then open parentheses, x bar. I'll just click on these values, x bar, minus mu. So that's mu, that's 1000. Close the parentheses, divided by, and then I'll open up another parentheses, s, is 250, and then I'll divide by the square root. This one I have to actually type in the square root of n is equal to 6. It looks like our test statistic is negative 3.337. So let's check that. Negative 3.337 rounded off to 3 decimal places. Let's make sure. 3371, so I think that's good. Next they want us to find our p-value. So remember that this is a less than sign, so it points to the left, and we didn't make a note of that, but this was a left tail test. And so when we're dealing with the left tail test, there's a special command to find your p-value. We're finding the area under the t-distribution curve, and you're finding the area on the left side of your critical value. So this number is going to be the t.dist command or formula. So let's type equals t.dist. Notice there's options here. The t-distribution is the left tail, tdist.2t is the two tail, and the tdist.rt is the right tail. So we're going to use the left tail test. And for this, if you want to check the formula, you can always click on the question mark. It's asking for the x value, the input of the t distribution function, and it's looking for the degrees of freedom, and then since we're looking for area under here, this is always going to be true. Okay, so our value comes from our test statistic, so it's going to be this number. Our degrees of freedom is going to be n minus 1, so 6 minus 1 is 5, and we're going to assume that this is going to be true. So our p-value is 0.0103. 0.0103. Compared to our significance level, this number, 0.0103, is less. So our p-value is less than a significance level. Whenever our p-value is less than significance level, we're going to reject the claim. And we're going to reject the claim. We're going to be able to support. I'm sorry, we're not rejecting the claim, we are rejecting the null hypothesis. And remember that the claim was the alternative hypothesis, so we rejected the claim. That means we should be able to support. There is sufficient evidence to support the claim. We rejected the null hypothesis, and so the alternative hypothesis is the claim. We're going to be able to support the claim. Okay. So what do the results suggest about the child booster seats meeting the specific requirements? So we rejected the claim, we rejected the null hypothesis, so we were able to support the claim. There's strong evidence that the mean is less than 100, but one of the booster seats has a measure greater than that. I can see that one of the measurement here is 1,162. So this looks like it would make sense. Let's take a look at B. The requirements met, since most of the sample measurements are less than 1,000. That's not the result of a hypothesis test. C. The results are inconclusive regarding to whether one booster seat could have measurement greater than. So this one would be an outlier, but all in all, I think it seems like it's less than 1,000, so I don't think it's C. And then D, there's not strong evidence that the mean is less than this and one of the booster seats is greater than. Well, the thing about the hypothesis test is we showed that there is evidence to support the claim, so I think the sufficient evidence gives a strong enough evidence, even though one of them is popping out. So let's try to check this. Okay, I hope that helps.